uh, maybe I should say polynomials from equations. Okay? And this, in fact, goes into a general topic called functional equations, which is in Olympiad is also very popular. And functional, but polynomials from equations. Okay? So, for example, I mean, just write any equation. So let us say, um, let's say that if I write the following, okay. So we have a um, find polynomial. Let me not even mention the degree. Find a polynomial satisfying the following. P of uh, P of x plus 1 minus, it's just maybe let us start with this simplest, okay? Is equal to 5. Can you find a polynomial that satisfies this? So a polynomial. So it's up to you, right? You can give any polynomial. So the answer will be simple, I think. Anyone? So just try the simplest thing. The simplest kind of polynomial that you can think of. Try one from there. You will get an answer. Another hint can be you can think about just arithmetic progression. Arithmetic progressions are like this. Right? They have a constant difference. Okay, I mean that this is true for all x. Okay, that's understood. Okay, no idea so far. Okay, let me say that assume that T is linear. Assume that T is degree 1, and then you try. Right? No ideas?
X plus 4.
X plus 4, right? Dx equal to x plus 4. Okay, I'll please check everybody, is this correct? So dx equals to x plus, maybe this function notation is it something new? Dx equals to x plus 4. So p of x plus 1 is just you put x plus 1 in place of x, right? So it comes x plus 1 plus 4, so it's just x plus 5. Does it work?
No.
No. This doesn't work, but something similar will work. Okay. But the easiest thing you can do is just assume that dx is ax plus b. Assume that you don't know anything, just dx equal to ax plus b. And now you go and try to find the a and b using you have these equations, right? You can see what a and b should be. So you have p of x plus, you have p of x. At x plus 1, it's that, and at x, it is this. And we just take the difference, and the difference is 5. You immediately see that the b doesn't play a role. You can put b to be anything. Right? This is like, it's 5x plus b. You can put b to be anything. Just take it to the 0. Doesn't matter. Because b doesn't play a role. You got whatever b, this will be satisfied. This p is equal to 5x. This is the easiest question in that sense. Okay. So you can just do this question without thinking also, in the sense that just assume it's a plus b, find a and b by putting values. Right? And in this case, it is just, in this case, sort of the values are not given, but this recurrence, this is sort of this is the equation, right? You are told that the polynomial satisfies some condition, that is, at the x plus 1 value and the x value, we take the difference becomes constant, right? And hence the polynomial, if you assume it is linear, then it is 5x plus 1. You can relate it with arithmetic progressions also. Anything is not clear, you should stop me. Then tell me. But the more interesting question, maybe, and try to get a feel for these things, right? I mean, the difference is a constant, then can Px be quadratic? Can Px be degree 2? Is it possible? There's the next question, right? Because if Px is degree 1, then it's done. Now, if Px is degree 2, we feel it should not be like the efficient test should not be possible. Kind of. But anyways, try see if Px can be. Plus anything. Again, if you don't want to think, you can just write. Okay, if Px is x squared plus ax plus b, then you put it in the equation and you see what you get.
The difference is coming a plus x to the ax.
Yes, okay, so the difference is coming what?
A plus b plus 2ax equals to 5.
A plus b plus, the last thing I cannot hear clearly. A plus b plus
2ax.
2ax. Okay. Yeah, something like right. And then it is not possible because it cannot be a constant. So, I mean, everybody can just try that. Look at this. Look at this. If you just put values, there's nothing to do. Just put values, put x equal to x plus 1, just hit and evaluate, get dx plus b plus. You take the difference, you get something which is impossible. You get this. And maybe you see is not that these. For all x. For all x, it has to happen. Can it happen? No. Right? It is x there. You can put different things and it will not be 5. So it's not possible. Not surprising. Nothing here is surprising so far. Okay. Now you can kind of feel this that it cannot be a higher degree also. You can take that as a homework. The degree of px cannot be more than cannot be it should not be more than quadratic, of course. But of course it's there, but you have to prove. You might be wrong. So what is the intuition, guys? I mean, anyone has so far any summary of what is happening? So we're not doing something very profound. How do you summarize all this? Meaning, if you do for 3, 4, and so on, but it cannot be a higher degree. The summary is, see, when you take these differences, right? When you take px plus 1 minus px, all it is doing, and it's a very good thing, it is bringing the difference down by 1, right? It is bringing the difference down by at least 1. This process, I mean, that is the main thing that is happening, right? That when you take a polynomial px, and then you take the difference, the degree comes down by 1. So my point is that this 5 is not important. It is a fact that the degree of this is less, at least 1 less than the degree of. Is it something that you agree with? Again, we have not proved it, but it seems like this is it. Take a minute and think about it. It is the highest term that gets cancelled, right? In px plus 1 and px, that always gets cancelled. And so the degree comes down by at least 1.
Yes.
Right? This is a very powerful idea. Very interesting idea. This, when you do calculus, you will also see differentiation also does this. Okay, differentiation, right, of x to the n is n times x to the n minus 1. Maybe you have at least have heard it, or I don't know, right? Degree comes down by 1. Right? Differentiation. We are not yet to the creation, maybe that part, but at least difference we are taking and we are seeing that. So this is like a finite. It's like a finite sort of a differentiation. It can be made precise. All that is called delta of dx. That is called d of dx. But for us, we learn this. So this is interesting. Now the next thing is we are sort of going into this other sort of direction, right? Understanding this growth and how polynomials change when you do this algebraic operation, right? What happens to the degree and so on. And then we'll come back to recurrence. The equation we'll have more harder equations, and we'll ask, find a polynomial. Is there a polynomial? We had asked such questions earlier. But the very next question that comes to mind is, can the degree decrease by more than? Again, seems what I don't. Can the degree decrease by more than? And yes, next week we will solve at least one problem, in the sense that all these are problems, and basically these are not like I'm just saying theory after theory. Right? It's the questions that we are solving along the way and covering the field. But we will also maybe solve one problem, one Olympiad question, like we are doing in the other class, the number theory class. We also started to solve questions. But can the degree decrease by more than? So now this question maybe you may not know how to start. Maybe start. I don't know. But I'll suggest you do this. Assume that px is a cubic and you try. Assume that px is cubic and you see. When you take this difference, do you necessarily get a quadratic, or can you get a linear? You take the difference and check. I'm not asking you to compute the difference, but just get to know whether the difference is a quadratic or can it also be linear. Find the difference and then you will know for yourself. Okay, don't think this is a computational question. You don't have to compute everything. You just know what you need to know, whether it's a linear. And these terms would matter. I'm not writing the linear terms. I'm just interested in knowing if the quadratic terms get cancelled. This is the quadratic term I'm getting from this. And this is the quadratic term I will have from the previous. When you take the difference, you get 3ax squared. A is not 0. B can be 0. C can be 0. D can be 0, but A cannot be 0. A cannot be 0 because otherwise it's not a cubic. Cubic, when it said it's cubic, it has to, A cannot be 0. And so this is a quadratic. Answer is no. So this is, so you can feel that this is not some random, it is not some, it's something very precise. This operation is something very precise, right? It decreases the degree by more than, by exactly 1. So it is decreasing the degree by exactly 1. Is it clear? Right? And just it is exact, right? And it is exactly how differentiation would also decrease the degree. It is 3x squared. This is exactly what differentiation would also do. Yeah. These are the things, right? This something is there, right? And then we will see connection of this with summation of series, arithmetic progressions. Obviously, you know the formula is a quadratic. The nth term of an arithmetic progression is an plus whatever, a first term plus n minus 1 times. But in terms of n, it's a linear, right? But when you take the sum of a arithmetic progression, then it's quadratic in n, right? When you take sum of arithmetic progressions, you get a cubic, and so on. Okay. So those things are there, and but we will come to that maybe later. But from that angle, also these things can be said very directly that this has to decrease by 1 from that perspective. But anyway.
Sir, what about when P has the degree is less than 1?
When the degree is less than 1, but then in that case the degree becomes 0. In that case it becomes a constant. I mean, oh, you say degree less than 1, right? It's a constant. Then the degree becomes, okay, then that's an interesting question. That's a very controversial sort of thing, in the sense that if this is a constant, yeah, then px plus 1 is also constant, right? All this. And so in that case, this difference, which is denoted by delta px, delta px is just what symbol I'm using for px plus 1 minus. This is 0. What is the degree of the 0 polynomial? There is no theorem like that, right? There's no theorem saying anything about this. It's just a definition that the degree of the 0 polynomial, we don't say it is 0. Because see, you can say it anything. It's up to you. You can say in the sense that the degree is this thing, right? That
the degree is undefined.
You can say it's undefined. Yeah, certainly that will also work. But see, saying that the degree is undefined is not a consequence of anything, right? It is sort of a statement on its own. It's a declaration, right? I mean, saying that the degree is undefined is not it's something that's written in the books, right? And maybe something we feel, okay, but the point is that there is nothing mathematically forces you to call that to say that it is undefined. It's not a consequence of other things. So it is in a way a convenience, but also calling it undefined is a very right thing to do for some reasons. It fits in the bigger picture, but will not go into that. One can say that the degree is infinite also. That also makes, but that is controversial for some other kinds. So the point is that these things are mostly something so that it fits in the bigger picture. Depending on what picture we are taking, where we are taking, what is where is our theory extending to, all those things. Then it should fit there. And some people, so yeah, in that case it's zero. But then that doesn't fit in my picture. You would say and it's fine. That's just that's case understood either way. So this operator is very nice. And what I've said is there's nothing profound about one here. Was there anything really profound about the one? I don't think. Right? We can put any number, any fixed number. Let's say any n. Check this. This is the whole check this. Check. If I'm incorrect, then you tell me. Okay. So check this, and if I'm incorrect, then tell me. Fine. There's nothing profound about the one. We never use the one. So this is two check. So now we will come back to our original uh, problem. Here we had this is the original. You can see that it's sort of like an arithmetic progression. Right? So if px is sort of the xth term of the arithmetic progression, then the x plus 1th term minus xth term is fine. You can put x to the n. Doesn't matter. Now let me along those lines. Let me ask this question, and let's see how. So this now find. Now I'm not saying any degree. Now it's up to you to find how you want. You can begin by finding a linear one if you can, or if you cannot, then find a quadratic. Just give me some answer to begin. Okay, try this. I just So, any ideas?
So for a linear polynomial, all the terms are getting cancelled.
Yes, so linear polynomial will not work. Linear polynomial will not
For quadratic, I got the value of c as 2.5 and dx plus c don't matter.
voice is not clear. Okay, so let's meet on the this meeting going to end. So just clear it out and then I'm ending the meeting. Just join.